Second Life electric vehicle battery marketplace for commercial and industrial storage market and business model assessment as of August 19, 2026. Used electric vehicle batteries are moving toward a major supply wave. At the same time, commercial and industrial customers need storage to reduce demand charges, support electric vehicle charging, and provide backup power. The opportunity is clear. Build a trusted marketplace that sells certified energy performance, not untested used batteries. The marketplace would connect fleets, vehicle repair centers, original equipment manufacturers, and recyclers with retired battery packs, battery testing and repurposing companies, commercial and industrial storage integrators, insurance companies, lenders, and project developers, businesses that need lower cost, behind-the-meter storage. The winning company will not simply match buyers and sellers, it will create the missing trust and financing layer through standard testing, digital records, performance warranties, and independent certification. Executive conclusion. A Second Life battery marketplace is commercially attractive, but the timing matters. The first large retirement wave from electric vehicle batteries will grow through the mid-2030s. A single cohort of approximately 1.5 million United States electric vehicle sales could eventually produce roughly 30 to 60 gigawatt-hours of usable Second Life battery supply, depending on retirement age, remaining capacity, safety screening, and repurposing yield. The United States has nearly 5 million commercial customers on tariffs with demand charges above $15 per kilowatt, according to a National Renewable Energy Laboratory survey. Even a 1% adoption rate among those customers could represent approximately 50 gigawatt-hours of storage demand if the average system size is 1 megawatt-hour. The largest barriers are not battery supply alone. They are battery data access, testing consistency, system certification, traceability, warranty design, and debt financing. The first pilot should use one fleet, one battery family, and one storage integrator. Mixed chemistries and open marketplace trading should come later. Why this market is forming now? Electric vehicle battery supply is becoming large. Global electric car sales exceeded 20 million in 2025. Global electric vehicle battery deployment reached approximately 1.2 terawatt-hours in 2025 and is expected to approach 3 terawatt-hours by 2030 under current policy and market scenarios. The United States sold approximately 1.5 million electric cars in 2025. The average battery size for a United States battery electric vehicle reached about 90 kilowatt-hours. These batteries do not become worthless when they leave a vehicle. Many still hold 70 to 80% of their original energy capacity. They may no longer meet vehicle range or power needs, but stationary storage is usually less demanding. Battery failure is also not the main source of future supply. Battery replacements due to failure were reported at only 1.5% across a large sample of model years 2011 through 2023, and below 1% for many vehicles from model years 2016 through 2023. Most future Second Life supply will come from vehicles reaching the end of their economic or physical life, not from batteries that suddenly fail. Commercial and industrial customers need peak power. Demand charges are based on a customer's highest measured power use, usually during a billing period. A battery can discharge during a short peak and reduce the customer's bill demand. The Energy Information Administration identifies reducing end-user demand and demand charges as one of the main uses of energy storage for commercial and industrial customers. For example, a business that reduces its monthly peak by 500 kilowatts on a tariff with a $15 per kilowatt demand charge could avoid 500 kilowatts times $15 times 12 months equals $90,000 per year. This does not include savings from energy price shifting, backup power, demand response programs, or reduced electric vehicle charging costs. The Department of Energy has also identified 50 to 300 kilowatt-hour battery systems as useful for reducing demand charges at direct current fast charging locations. This creates a strong first market for Second Life batteries. Fleet charging depots, warehouses, cold storage facilities, manufacturing plants, retail centers, data centers, agricultural facilities, schools and public buildings, electric vehicle charging hubs. Market size using retirement curves. A credible market estimate should separate battery supply from storage demand. These are different markets with different timing. Planning assumptions. The following model is not a published forecast. It is a transparent planning model that can be updated as better fleet data becomes available. For the full table, please open this article on marketgapideas.com. The 80% battery electric vehicle share, screening yield, average storage size, and installed cost are modeling assumptions. They should be replaced with actual fleet and integrated data during the pilot. Retirement curve. The Department of Energy estimates that modern electric vehicle batteries may last approximately 12 to 15 years in moderate climates and 8 to 12 years in extreme climates. Climate, charging behavior, battery chemistry, thermal management, and vehicle use all affect battery life. A marketplace should therefore use a retirement probability curve, not a single retirement year. A practical starting curve could look like this. For the full table, please open this article on marketgapideas.com. This curve is a starting assumption. A fleet may retire batteries earlier because of range requirements, accident damage, warranty rules, vehicle replacement, or changes in route duty. Another fleet may keep vehicles and batteries in service much longer. Battery supply from one United States sales cohort. Using the 2025 United States sales cohort, 1.5 million vehicles times 80% battery electric vehicles times 90 kilowatt hours equals 108 gigawatt hours of original battery capacity. If those packs reach retirement with 70 to 80% of their original capacity, they contain approximately 76 to 86 gigawatt hours of remaining energy. If 40 to 70% pass safety, cost, and application screening, the usable second life opportunity from this one cohort is approximately 30 to 60 gigawatt hours. This supply would arrive over several years, not all at once. If distributed across 4 to 6 retirement years, the cohort could provide roughly 5 to 15 gigawatt hours per year for second life use. This is a planning estimate, not a guaranteed supply forecast. Actual results will depend on vehicle retirement age, pack damage and accident history, access to battery management system records, battery chemistry, pack repair cost, transportation cost, testing yield, competition from recycling, prices for new stationary batteries, commercial and industrial storage demand. The National Renewable Energy Laboratory identified nearly 5 million United States commercial customers that could subscribe to tariffs with demand charges above $15 per kilowatt. The original survey was published in 2017, but the underlying tariff dataset was updated in 2024. Applying simple adoption scenarios. For the full table, please open this article on marketgapideas.com. At an illustrative installed value of $250 to $400 per usable kilowatt hour, this represents. For the full table, please open this article on marketgapideas.com. These figures are cumulative opportunity estimates, not annual revenue forecasts. They include equipment, power conversion, controls, installation, commissioning, and service. The key market insight is that commercial and industrial demand could be much larger than near-term second-life battery supply. This gives a marketplace room to work with multiple sources, including retired electric vehicle batteries, new batteries, factory overstock, and refurbished modules. What the marketplace should sell. The marketplace should not list a battery as used or 80% healthy. That language is too vague for a lender, insurer, or commercial customer. Each listing should contain a standardized battery performance certificate. Required battery record. Every pack should have a permanent digital record containing battery manufacturer, vehicle manufacturer and model, battery chemistry, pack, module and cell identifiers, manufacturing date, vehicle identification number, where available, vehicle mileage and operating hours, climate and location history, charging history, direct current fast charging exposure, maximum and minimum state of charge history, previous repairs, accident, flood, fire, or thermal event history, recall status, warranty status, date removed from the vehicle, ownership and title history, transport and storage records, recycling or final disposition plan. The National Institute of Standards and Technology identifies battery traceability and battery passports as important tools for managing battery reuse and recycling. It also highlights the need to track information throughout a battery's life. Marketplace battery grades. The marketplace could use its own commercial grades. These should not be confused with official underwriters' laboratories' grades. Grade A, high-value stationary storage, strong remaining energy capacity, good power capability, low cell imbalance, complete usage history, suitable for 2 to 4 hour commercial and industrial storage. Grade B, lower power stationary storage, lower power capability or greater capacity variation, suitable for longer duration backup, solar shifting, or low-rate applications, may require more conservative operating limits. Grade C, component recovery, not suitable for complete system use, may contain usable modules or cells sent to a controlled repair or recycling pathway. The listing should show measured usable energy, not only original nameplate capacity. Proposed testing and certification standard. The marketplace should build on existing standards rather than create a competing safety system. Existing standards ANSI CAN UL 1974-2023 covers the sorting and grading of used battery packs, modules and cells intended for repurposing or remanufacturing. It was published on November 10, 2023. UL 1973 applies to batteries used in stationary applications. UL 9540 applies to complete energy storage systems. UL 9540A provides a test method for evaluating thermal runaway and fire propagation at the cell, module, unit, and installation levels. National Fire Protection Association 855 covers installation, commissioning, operation, maintenance, and decommissioning of stationary energy storage systems. The 2026 edition includes specific chapters for electrochemical storage and lithium-ion battery storage. The 2024 International Fire Code states that batteries previously used for electric vehicle propulsion cannot be reused in covered energy storage applications unless approved by the Fire Code official and refurbished by a company approved under UL 1974. IEEE 2993-2025 provides a recommended practice for designing energy storage systems using second-life electric vehicle batteries at voltage levels of 10 kilovolts and below. Proposed testing workflow. For the full table, please open this article on marketgapideas.com. A strong certificate should report usable energy at a defined temperature, continuous power, short duration peak power, round-trip efficiency, cell voltage spread, temperature spread, insulation resistance, maximum operating temperature, allowed state of charge range, equivalent full cycles, expected degradation, prediction confidence range, recommended application, required inspection interval, end-of-life trigger. The major improvement is to report uncertainty. A certificate should say, for example, the pack has 61 kilowatt-hours of usable energy at 25 degrees Celsius with a measurement uncertainty of plus or minus 1.5 kilowatt-hours. That is much more useful than saying the battery is about 80% healthy. Warranty and performance certification. The marketplace should make warranties simple enough for a business owner and detailed enough for a lender. Recommended initial warranty structure. For the first commercial pilot, the marketplace could offer 5-year capacity warranty, minimum end-of-warranty usable capacity floor, guaranteed system availability, guaranteed energy throughput, defined operating temperature and state of charge limits, replacement or derating remedy, service response time, fire and product liability coverage, transferable warranty for the remaining system life, defined recycling responsibility. The capacity floor should be based on certified starting usable energy, not original vehicle capacity. For example, a battery system certified at 1,000 usable kilowatt-hours could have a contract capacity floor of 700 to 800 usable kilowatt-hours at the end of the warranty period. The exact level should be based on measured degradation data and the planned operating profile. Some existing companies show that longer warranties and financing models are possible. Smartville publicly lists a 10-year warranty and 3,000 cycle specification for one system. Connected Energy offers leasing, battery storage as a service, battery replacement terms, and availability guarantees. B2U advertises insurance-backed performance warranties and financing options. These are company-reported terms, not a universal market standard. The marketplace should standardize the contract language so buyers can compare systems from different suppliers. Comparison with existing programs. For the full table, please open this article on marketgapideas.com. Nissan's 4R energy model uses different grades for different applications and reports approximately 10 to 15 years of additional life for some recovered batteries. Mercedes-Benz reports stationary projects, including a 1,400 kilowatt-hour factory system and a planned project exceeding 5 megawatt-hours at an airport. Smartville has demonstrated a system combining packs from different manufacturers and has received Department of Energy support from multi-state Second Life storage demonstrations. Moment Energy announced in 2026 that its battery management system had been recognized as a component for UL 1973 and that it was building a broader UL compliance framework. That announcement should be independently verified during commercial due diligence. The open market gap is therefore not a total lack of solutions. The gap is a neutral, comparable, finance-ready standard across multiple suppliers and battery families. The main industry gaps: battery data is often unavailable. Repurposers may not receive complete battery management system data from the original vehicle manufacturer. Without first life data, testing becomes more expensive and degradation predictions become less accurate. This is one of the most important policy and business gaps identified by the American Council for an Energy-Efficient Economy and the National Institute of Standards and Technology. A safety standard is not the same as a performance standard. UL 1974 helps define the repurposing process. It does not create a universal marketplace rating for usable kilowatt hours, remaining useful life, energy throughput, power fade, warranty value, residual value. The marketplace should fill this gap with measured, repeatable performance data. Different battery packs are difficult to combine. Packs differ in voltage, chemistry, cooling method, communication protocol, cell format, power limits, state of charge range, battery management system design. A marketplace should initially avoid mixing unrelated battery families in the same system. It should begin with one battery platform and expand only after the control system has been validated. Financing is difficult without a warranty backstop. The Department of Energy Loan Programs Office identifies lack of debt financing, perceived technical risk, and unpredictable cash flows as major barriers for newer storage technologies. A lender will ask, who owns the battery? Who replaces a failed pack? What happens if the repurposer closes? Is the warranty transferable? Is the system insured? What is the liquidation value? Who pays for removal and recycling? How accurate is the degradation model? The marketplace must answer these questions in the sale contract. Permitting is local and inconsistent. A system may satisfy a technical test and still face delays from a local fire code official, utility, or building department. The marketplace should provide a complete permitting package with UL certification records, UL 9540A results, battery performance data, fire safety plan, emergency response plan, site layout, ventilation and detection design, commissioning report, decommissioning plan. Financing models to test. The marketplace should test several structures instead of assuming customers will buy batteries outright. Direct sale. The customer buys the system and receives 5 to 10-year warranty, operations and maintenance contract, capacity and availability guarantee, optional replacement reserve. This is simplest, but may require the customer to provide more capital. Lease. The customer pays a fixed monthly amount. The provider owns the system and retains the residual value. This model may work well for small and medium commercial customers. Battery storage as a service. The provider owns, operates, maintains, and warranties the system. The customer pays for guaranteed availability or shared savings. Connected Energy already advertises a battery storage as a service model that includes installation, software, maintenance, warranty, replacement parts, and availability guarantees. Energy throughput contract. The customer pays for delivered energy or avoided peak demand. The contract includes a capacity floor and a replacement obligation. This is attractive because it changes the customer's purchase from buy a used battery to pay for dependable peak shaving capacity. Tax credit and depreciation review. United States energy storage placed in service after December 31, 2024 may qualify for the Clean Electricity Investment Credit under Section 48E. The base credit is 6%, increasing to as much as 30% when prevailing wage and apprenticeship rules are met. The credit may also be transferable or available through elective pay for eligible entities. Domestic content, energy community, prohibited foreign entity, original use, related party, and used equipment rules can affect project eligibility. A Second Life storage project should not include a tax credit in its financial model until Tax Council confirms the treatment. Validation plan. one fleet, and one storage integrator. The proposed marketplace should be validated through a controlled commercial trial. Fleet partner. Select one fleet with at least 50 retired or replacement battery packs, 1 or 2 battery families, complete vehicle mileage and charging records, known operating locations and climate, permission to share battery management system data, a defined retirement and recycling process. Good candidates include delivery fleets, transit bus fleets, municipal fleets, rental vehicle fleets, airport vehicles, utility service fleets. The fleet should provide the packs at the point of vehicle removal, before they are mixed with unknown inventory. Storage integrator. Select one commercial and industrial storage integrator that already has a listed power conversion system, energy management software, demand charge control capability, fire and safety engineering experience, utility interconnection experience, a commercial customer willing to host the pilot. The first system could be 250 to 500 kilowatts of power, 1 to 2 megawatt hours of usable energy, located at a fleet depot or commercial facility, connected to solar, electric vehicle charging, or both. Trial phases. Phase 1. Data and inspection. Duration, 8 to 12 weeks. Tasks. Collect all available first life data. Complete ownership and recall checks. Inspect and photograph each pack. Perform electrical and insulation tests. Assign preliminary grades. Compare battery management system estimates with measured capacity. Phase 2. Controlled testing. Duration, 8 to 12 weeks. Tasks. Measure usable capacity. Measure power capability. Test cell and temperature balance. Establish safe operating limits. Run accelerated cycling. Train the degradation model. Reject unsafe or uneconomic packs. Phase 3. Field deployment. Duration, 12 to 18 months. Tasks. Dispatch the system for demand charge reduction. Record energy throughput and operating temperature. Perform monthly or quarterly capacity checks. Compare predicted and measured degradation. Track customer savings. Collect lender, insurer, and permitting feedback. Pilot success metrics. For the full table, please open this article on marketgapideas.com. The most important technical metric is not initial capacity. It is degradation prediction accuracy. A buyer can manage a battery that slowly declines. A buyer cannot easily manage a battery whose remaining life is unknown. Recommended launch strategy. First 6 months, choose one battery family, sign one fleet and one storage integrator. Build the digital battery record. Align the testing process with ANSI CAN UL 1974-2023. Select an independent testing laboratory. Establish the first warranty form. Create a pack-level chain of custody process. Months 6 through 12. Complete controlled testing. Deploy a 1 to 2 megawatt-hour commercial system. Measure demand charge savings. Train the degradation model. Collect financing term sheets. Complete permitting and insurer review. Publish anonymized performance data. Year 2. Add a second battery family. Add a second fleet source. Introduce battery storage as a service. Create an insurer-backed warranty pool. Offer a standardized lender data room. Expand into electric vehicle charging depots and industrial facilities. The company should begin as a closed-loop marketplace, not a completely open exchange. A controlled supply chain makes it easier to verify ownership, collect battery history, manage transportation, and support warranties. Final assessment. The Second Life electric vehicle battery market has a strong long-term supply outlook and a large commercial and industrial demand pool. Demand charges provide a clear customer benefit, while fleet charging and backup power create additional value. However, used batteries will not win simply because they are cheaper. New batteries are becoming more competitive, and commercial customers care about uptime, safety, financing, and accountability. The strongest business model is therefore a certified Second Life storage marketplace with traceable battery records, standardized testing, application-specific performance ratings, insurance-backed warranties, and financing-ready contracts. The first proof point should be a single fleet-to-storage project. If that trial demonstrates reliable energy throughput, accurate degradation forecasts, measurable demand charge savings, and acceptable financing terms, the marketplace can scale from a testing service into a national infrastructure platform. All links to sources are available in the text version of this article. You can find the full article at marketgapideas.com/blog. Thanks for listening. This episode was produced using autopod.co, the platform that turns deep research into podcasts, articles, and SEO content automatically. If you want to create content like this for your brand or business, visit autopod.co and see what automated content marketing can do for you.